So, sucker rod pump, let us draw first one sucker rod pump. One sucker rod pump is like this. I have one walking beam. Okay, walking beam will have one horse head. I said it will be like arc, and it will have my Samson post. Simplified drawing I am doing, Samson post, and there will be one tail pin. Tail pin is connected to my pitman arm. Pitman arm to my crank. Crank will be connected to one big mass called counterbalance mass. Okay, this is counterbalance mass. Counterbalance mass, here will be one pin also. Okay, so there will be one gearbox. Okay, and there will be one pulley here, back side a sheave. So sheave will be connected to your motor sheave. Sheave will be connected to your motor sheave. Okay, so here one motor will be here. Okay, motor, here will be sheave. This will be V belt normally. I will explain later what is V belt and why it is used for oil industry application. And there will be one gearbox, and this is called crank. This is called counterbalance mass. Counterbalance. This is pitman arm. This is tail pin. This is walking beam. This is saddle bearing. This is horse head, and horse head will be connected to bridle or wear line. Wear line will be connected to your polish rod. Polish rod will go into wheel bore, and there will be one stuffing box. Stuffing box. Stuffing box, and there will be one T section. Okay, T section, there will be some gas venting pipe also. Okay, this is going to well bore, and this is sucker rod pump. Sucker rod pump is here, and this is sucker rod. Okay, and this is tubing, and casing will be here. Casing is like this. Okay, so this way the whole sucker rod pumping system you can draw. Now here I said like three types of, basically three types: conventional, Mark II, and air balance system. But if you search Google, here I have given one link also. If you see there are several other types of sucker rod pumping systems also available. The most common, Lupins and Weatherford, they are making these three types of system. Okay, so one conventional system, this is conventional system. Conventional sucker rod pump, and another is called Mark II. What is Mark II? Mark II is like this. I have one walking beam, okay, and Samson post. Mistake. I'll draw like this. I have Samson post is this, and I have beam here, horse head is here, and my pump is here, and my power will be given here. Okay, mass is here. Okay, power will be given from here. Okay, so you can see the basically both are same, only this rotation motor location is changed. Motor location changed from one end to in between your saddle point and horse head. Okay, this is Mark II. One company, Lufkins, they made this Mark II sucker rod pump. Another is called air balance unit. Air balance unit will be like this, similar to Mark II. Then you have like this, but instead of counterbalance you are giving air compression system. Okay, this is air compression system. So counterbalancing. Okay. So, this is called air balance unit. Okay. So, you see the three system difference, and many company they are trying to develop long stroke sucker pump also. In that case, sometime they are using a linear generator type thing, sometime they are using some gear mechanism, so that instead of whole beam and this Samson post everything they are replacing, and they are making directly long stroke like this. Maybe they will have one gear mechanism and a rack is like this, and if you rotate this gear continuously positive and negative direction, the rack will be moving up and down, continuously up and down. And the rack means this is one straight beam and it will have lots of gear teeth. I'll explain later what is that gear teeth. Okay. If you give rotation to this pinion, the rack will be moving up and down. So, normal sucker pump stroke length will be like 74 inches, 40 inches, 50 inches, but this type of linear stroke based system, they are having stroke length like 25 feet, 20 feet. So, very long stroke they are creating. They are saying these are better because you can run slow speed and very long speed. So, many type of problems will be resolved. So, many other type of sucker and pump also may be available, are available already. So, please go through the link there given in the slide. Now, I said like the sucker rod pump or beam pump will be run by one motor or IC engine, that is called prime mover. So, what is motor? Motor actually electrical system. Motor will be electrical system. So, here you have one magnetic coil plus magnet. Okay. Both when acting together, it will give torque to a shaft. Okay. So, the shaft torque will be transferred to your sieve or small pulley. So, the small pulley will be connected to your V belt. Okay. So, that V belt will be connected to bigger V belt, bigger sheave. When bigger sheave is connected to again gearbox system, then you are reducing speed. Normally, this motor speed will be like 700, 1400. So, very high speed motor is there actually relative to your sucker pump stroke. Sucker pump stroke will be 6 to 20. Sucker rod pump speed will be 6 to 20 SPM or stroke per minute. So, 6 to 20 SPM means 6 to 20 rotation of crank. Okay. So, crank is like this. Okay. This is crank and pitman arm to your beam pump, walking beam. Okay. So, this rotation N and this horse head SPM, RPM. So, RPM SPM will be same. So, one rotation means stroke per minute, 2 stroke. Okay. So, 1 stroke up stroke, down stroke, 2 stroke. So, 1 rotation 2 stroke you will have. So, if you want to get stroke like say 6 to 20 stroke per minute, so in that case your crank rotation also will be reduced accordingly, and 700 to 40 rotation you have to make at let's say 10-20 rotation you have to get. So, when you are getting that much of lower rotation, you cannot do in one go, you have to go with multiple steps so that you can reduce speed. These days there are VFD or variable frequency drive also available. So, if you are using VFD or variable frequency drive, again you can reduce further speed or you can increase the speed also as per requirement. So, motor if it is running without any load, so it will be giving very high speed. Now, when if you are loading it, so some speed will be reduced. So, how much speed will be reduced? It will be calculated using your slip calculation. Slip equals motor slip, they are saying slip S equals NS minus NF NS into 100. So, synchronous speed and NF is a nominal full load speed, nominal full load speed. into 100. So you can this is called motor slip. Okay. So if you don't have any load, then your speed will be very high using one tachometer. When you are measuring speed, that is called the speed sensor or speedometer, or sometimes they say, sometimes they say tachometer. Using one tachometer sensor, if you put there, so tachometer, what will it do? It will check how much speed is there. So how they check tachometer? Tachometer will be giving some light signal here. Let's say this is one shaft. Okay, here will be a reflector glass. Now using tachometer instrument, you give some light source on this glass. Okay, when this is rotating, so one time reflection will come to, it is rotating very fast, reflection rate will be very high, and the tachometer will be sense that reflection rate. So because of this number of reflection rate will give its speed sense. Okay, so this free handheld devices available in the market. So this tachometer will be giving speed. So initially without load you try to check, so that will be synchronous speed. Then you load the motor and see how much speed is getting reduced, that is called slip. So based on that you can get, okay, this much of slip is there, so my motor speed will be within this range. So within this range is speed there, and I need this much of stroke per minute. So that means my system will be changed, or you have to give higher power motor or lower power motor, or based on that you have to decide, you have to select your motor. Let's say one problem. An induction motor is having speed 1200 rpm. Okay, and after loading your tachometer sensed it is 1000 rpm. Okay, after loading, or you connected to your sucker rod pumping system and you get 1000. What is slip? SLIP, slip equals 1200 minus 1000 divided by 1200 equals 12.5% into 100. Okay, this much of slip will be there. Now let us see IC engine. So many times the surface unit will be powered by motor if electric connectivity is there. If connectivity is not there, then you have to use IC engine or internal combustion engine. Internal combustion engine is nothing but 2-stroke engine or 4-stroke engine. It can be run by diesel, petrol, or maybe whatever gas you are getting from wellbore, that can be also used for running the IC engine system. Like say IC engine, if you have inaccessible area, then IC engine will be good, but if you have accessibility of electricity, then okay, good, you can use motor. Now what is 2-stroke engine, what is 4-stroke engine? 2-stroke engine, actually it will be giving a very high power, but pollution rate may be higher. But 4-stroke engine, it will be giving little bit lower power, but there are big units are there, it will be giving very high power also, but pollution level will be very low in 4-stroke engine. I will discuss later how this 2-stroke engine, 4-stroke engine works. So normally 2-stroke engine speed will have 750 rpm, 2-stroke engine, and if you have multi-cylinder engine, so speed can be 2000 rpm. Okay, in 4-stroke engine, 4-stroke engine. Okay, and 15 to 325 horsepower engines are available for this oil and gas industry applications. And if you want to change speed, again you have to go through your V-belt, pulley system or sheave system, then gear mechanism, then pitman arm, then walking beam, then your horse head, bridle and polish rod, then you are going to sucker rod, and sucker rod will be transferring power to your pumping system or downhole system. So what is V-belt drive? If you see the picture, this picture says that V-belt is having one pulley, this is called sheave, and one bigger pulley is there. Like you have one cycle is having smaller pulley, or sprocket system is there, or wheel, small wheel is there, big wheel is there, and connected by chain, like small wheel, big wheel connected by chain. Why the small big is there? Because of small big, actually you are changing speed. So your pedal is here. Okay, your pedaling rate say 10 rpm for example. Okay, 10 rpm, but this rpm will be increasing to maybe 20 if diameter is different. Let's say d1, d2. If diameter d2 and d1 ratio, d1 by d2, 2, d1 is double, then actually you will be increasing speed to 20 rpm. Okay. Again, this small wheel is connected to big tire, right? Sprocket are there, spokes are there, and big tires are there. Okay. So because of big tire is connected, so your speed will be higher. These days there are cycles with multiple gears. Multiple gears implies you can change speed also. So if you look at the multiple gear or geared cycle, so they will have different size backside. That small gear is there, gear. Okay. So that's a small gear, big gear, different types of gears will be there, and if you change the gear, actually you are changing your speed. That means your d1 and d2 ratio changing. d1 is almost fixed for all the cycles, but d2 you are changing. Because of d2 change, your cycle speed will be changing. For same speed, for your same pedaling speed, your cycle velocity will change, but you may have to work more because power you are not changing. Although you are changing speed, power will be same. Okay, you should remember, when you are changing speed using your gear mechanism, we are assuming that there is no losses or almost no losses or negligible losses is there when you are transferring power from big wheel to small wheel, or you are changing speed. So power will be same, but torque, the omega or rotational speed will be changing only. When you are transferring power from motor to your pitman arm or sucker rod pump, so in that case you are using one V-belt. It may be chain also, but normally people will be V-belt. So chain and V-belt difference is there. Chain is metallic, complete metallic. Chain, if you see the picture, chain will be like this. Chain will be having wheel, and again it will be like this, again it will be like this, it will be connected like this, and it is completely metal. So there is no flexibility, no friction. But if you are using V-belt, actually V-belt, this belt whatever you have, so belt, if I take cross section of certain area, for example this one cross section will look like almost V. Okay. And the pulley shapes or sheave, the sheave shapes will be like this. Sheave will be like this, and number of belt will be like 3, 5, 7. So in normally odd number belt will be there. Okay, and belt will be placed like this here. Okay, and because of this special shape of the groove on the pulley or sheave, and the shape of belt is also triangular, so it will be catching properly. So friction will be very high, because friction formula, if you can remember, the surface area also matters. Is surface area increased because of V shape, and whenever load is higher, the belt will be pushing down on the groove, so it will get more friction actually. So it will not be sliding, and normally it will be made of rubber, cotton, or some other material, so very softer material, so that continuously rotating, it is getting continuous bending action. So because of this bending action, it will not fail. So chain drive also can be used, but chain is heavier. So if you have very high speed and very long application, so chain maintenance will be very difficult. But in V-belt, belt is very lighter, so very high speed also okay, less maintenance will be okay. And V-belt will be giving certain flexibility of high load carrying capacity and safety operation also, because it can extend, it can slide also if it is having some blockage somewhere in the machinery system. Now gear system. So belt, gear, chain, these are actually power transmission system. How you are transferring power from motor to your pitman arm. So motor is here, motor, then motor shaft will be connected to a sheave. Okay, sheave is connected to one belt, this V belt, then again another big sheave. Big sheave shaft will be connected to gear mechanism, gearbox. Then gearbox will be connected to one crank. Okay. Now purpose of V-belt is transferring power and to reduce speed also. In cycle, you can see your cycle pedaling that gear has been larger diameter, and back wheel connected that gear is having lower diameter. So, higher diameter to lower diameter actually you are increasing speed, but in your motor to your gearbox you are using V belt. So, there actually motor side will have lower smaller size gear and gear side will have larger side gear, the larger side sheave. So, in small sheave, larger sheave. So, what is happening, sheave or pinion or wheel we can say. So, there actually we are reducing speed. Again, if you are changing, let us say D1 and D2, if double, so your speed will be half. Okay. Now, if your two shafts are very close together, so in that case normally you are not using belt or chain, you are using gear mechanism. Gear will have efficiency very high, so power losses will be almost low, and again you have to do properly lubrication, otherwise friction will be high. So, in all the cases lubrication is required because you will have friction surface in certain cases. Okay. So, in gear if I draw like this, gear will be looking like this. Gear teeth will have, these are called teeth. Okay. And gear teeth shape will be like this. This is curved, flat, curved, curved, flat, curved, flat, curve. Okay. So, whenever you are drawing gear, you make like this. First, you make initial circle, then curve, flat, curve, 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 flat, curve, flat, curve, flat. Okay. So, this is my measurement wrong, manually I am doing. So, that's why this happened. Okay. So, this is my gear, this is called teeth. Sometimes they say gear wheel, these are teeth. So, when two gears are meshing, here you see this gear A, gear B, when two gears are meshing, their teeth will be same shape and size. Okay. Big wheel or small wheel, teeth must be same. What happen if I have different teeth, then both gear will not be rotating each other. Let us say draw one smaller gear. Okay. Flat like this. Okay. So, this is smaller gear, and okay, now not looking very good because manual drawing. Anyway, so but I want to see whether you are drawing proper curved, flat this way, and both gear if you are not same, what is happening, big teeth, small teeth cavity will not go. If it is very small gear, then cavity in between, two teeth in between the gap, this gap will not be sufficient enough to take big teeth size. Okay, that is why both teeth must be same shape and size, so that both can match together. If it is one is a very big gap, one is a small gap, it small will go, but when small gear will have a small gap, it will not go. So, what will happen when it is rotating? So, one gear will not match properly to other. So, when it is not matching, it will not rotate. So, both gear must have same shape and size. Then how the power will be transmitted, big and small? So, number of teeth will be changed. Okay. So, number of teeth is changed, not shape and size. Okay. Number of teeth is changed. So, here T1, T2 and D1, D2. Okay. So, teeth number will change, diameter will change, and diameter ratio and teeth ratio will be same actually. So, big diameter will have larger number of teeth, smaller diameter will have smaller diameter teeth, but teeth shape and size must be same. Okay. One gear is called driving gear, and another gear who is getting power from gear, the main gear, this is called driven gear. So, if I have power here, I am giving power rotation this one, I will get rotation here, right. So, this is rotation, this is rotation. Okay. And rotation will be opposite, if you want clockwise and another will be anti-clockwise. So, if A is giving power, it will be driving gear, and B is getting power, that means driven. Okay. In pulley case, your rotation, if you see cycle sprocket, if you see that chain drive, so both are rotating same direction, right. If you pedal it, your wheel also rotating same if it is clockwise, your wheel also rotating clockwise. So, your direction not changing, but in gear direction changing. Okay. One more belt arrangement will be there, cross belt arrangement. In some cases people are using here one pulley, here is one pulley. So, in that case actually rotation direction will be opposite, but normally we are not using for your sucker pumping application, we are using straight, okay, without crossing. So, without crossing, when you are using our speed direction is changing, speed changing, direction not changing for V belt chain application, but for gear application speed changing, direction also changing. Okay. If it is a single reduction gearbox, so this one actually single reduction, only one gear driving, one is driven. But if you have multiple gear, one driving, driven, something like that, then it will be double gear, triple reduction. Okay. And this will be put inside a box called gearbox, and gearbox will be heavily lubricated, because we do not want friction between the gears. If it is friction is there, then lots of heat generation will be there, friction will be there, and life will be lower, and system can fail. So, it will be filled properly with lubrication. So, lubrication means low friction and life will be longer. Okay. Now, whenever you see sucker rod pump, they will be saying double reduction gearbox, and PCP also, many other surface application, well, downhole application use actually gear. And not only oil industry application, there will be some other industries also, truck, bus, train, your bike, your bicycle, many places you are using gears or chain drive or belt drive. Okay. Here double reduction gearbox is normally used in your nomenclature in SRP. So, what is that actually I will explain. So, double gear reduction gearbox, like it must be a box. Okay. It must be having one box. So, inside box, what I said, it will be filled with some lubricant. Okay. It will be having some lubricant inside. Lubricant means lots of high viscosity fluid like mobile oil, or if you go to any bike shop, there will be some engine oil. So, Caster will be there, Mobil will be there. So, different company they may making their different quality of lubricating oil, and based on the temperature and other condition also lubricating oil or lubrication system will be changed. So, how this double reduction gearbox is happening? So, it will have one box will be driving shaft. Okay. And driving shaft will be giving power to B, power to A, it is giving power to A. So, A gear is rotating and A gear is rotating, A gear will be giving rotation to B. So, B will be rotating its shaft. Okay. Shaft is connected to C. So, this will go to bearing actually. Okay. These are bearing. So, C will be driving D, D will be having final driven output shaft. This is input. Okay. So, input shaft is giving rotation to A or torque to A driving B, B is directly connected to C. So, C is also rotating, C rotating. So, D also rotating because C and D connected. So, D rotating means you are getting output shaft torque, rotation and torque. Okay. How does it look like? If you see this top picture, here I can, how can I say, let us say this one A, this one B, this one C, this one D, although size is different. Okay. So, or I can draw another picture, bigger, smaller gear is there, then little bit bigger is connected, and this is connected to one smaller is connected to D. Okay. Oh, now okay, now I can resemble my picture left side. This is A, this is B, this is C, this is D. So, my A shaft is here, this is A shaft, okay, this is input shaft, this is output shaft. So, what is happening in between two? A rotating B, B and C connected. So, what is the speed of B and C? You see this picture also, B and C speed or RPM will be same because these are directly connected. It is not connected by gear meshing, right? Shaft are same, so same shaft rotation will be there. So, if it is having 100 RPM, this will be if this is having 100 RPM, this will have 100 RPM, all right. But A and B RPM will be different, B, C RPM same, C and D RPM will be different. So, C and D, if I see RPM, so D RPM will be lower, right, less than 100, and A RPM will be higher, more than 100, right. So, if A RPM let us say 1000, B RPM will be reduced maybe 500, so C RPM will be 500, again D will be less than 500, maybe 400. So, 1000 to 400 we can get, okay. Now, you see the problem, A number of teeth 7, you see the problem, okay. Number of teeth in A, TA 7, B, TB equals 21, TA equals 7, and TC equals 9, TC equals 9, and TD equals 30. Okay. So, the first gear ratio is the ratio of the teeth or diameter ratio and gear ratio same actually. So, gear ratio first gear ratio 7:21 here, in this case 7 and 21. So, 7:21, and second gear ratio C and D 9/30. Okay, if you see 9 and 30. So, if input speed is 700, what is the output speed? So, let us say A 700 RPM, what is the B RPM? B RPM will be reduced, right. 700 into 7 divided by 21, and what is the C RPM? Same, right. You got C RPM. Now, what is the D RPM? C RPM further reduced, 700 into 7/21 into 9/30. So, what, how much? 33370. Okay. So, D RPM is 70. So, initial RPM I gave 700, finally it becomes 70, fine. So, how the double reduction gearbox is working. Now, if I give you triple reduction, say small gear, and small gear is here, big gear connected, the small gear is connected to another big gear, then this is here another big gear. So, many type gear I can connect, I can give number of teeth, you can calculate, or diameter ratio also same actually, right. So, a double reduction gearbox reducing the speed in 2 times, input speed NA, output speed ND, speed reduction from NA to NB, again NC to D, power T omega, power is not changing, you please remember power is not changing. So, torque can be changed with T into omega, okay. So, power is not changing, torque is changing, but what is the direction? If A clockwise, B anti-clockwise, right. If you see this problem, A clockwise, B anti-clockwise. So, A clockwise, B anti-clockwise. So, C also anti-clockwise. So, D will be clockwise, fine. So, in many places people use differential gearbox or normal gearbox. So, it will be double reduction, triple reduction or single reduction. If let us say 7:10, if I want to make single reduction gearbox instead of double reduction, what will happen? So, you have to make gear ratio 700 divided by 70. So, 10 gear ratio you must have, gear ratio 10. So if one TA7, then my okay, so small gear and big gear will be there, right? So if it is 10, so it must be 100 if its diameter 10 centimeters, say, okay, centimeter, so it will be 100 centimeter. So one small gear and another will be very big gear. So in many places, if we don't have, in many places if you have space constraints, so in that case we cannot use single reduction gearbox. Single reduction gearbox means one big wheel will be there and one small wheel will be rotating. So the space constraint may be a problem. But if you are using gearbox, that will be very easier to handle because it will be very compact box and lubrication, everything will be there inside. And many places people are using to reduce the double reduction or triple reduction gearboxes instead of single reduction gearboxes. But if speed reduction is not so high, so in that case you can use single reduction also.